So I would say for Earth, the period equal to 1, and 1 is 1 year. And is A is the distance measured, the average distance between the Earth and Sun over the year. So here we scale is 1. So here is we call the AU, Astronautic Unit, and that is taken as the average distance between Earth and Sun. And then in this way, the t squared equal to 1 and a cubed equal to 1. So this constant can be calculated as 1. And the other example is the Mercury. And for the Mercury, here we listed the time is about 0.24 of the Earth's time, so which means the 0.24 year, Earth year. And the distance in average we can measure is 0.39. Okay, and so in calculations, this is about 0.39, and this is 0.37. So a little bit deviations, and that one is due to the here this one is due to the two-body theory. Okay, so here we measured is the true measurement. So etc. So I forgot which table, but I think this is probably maybe from our textbook. Okay, so here if you're interested, you can find out the other planets and see. Okay. So that is the for the elliptic orbits, and here I want to, before we move to the examples here, and for elliptic orbit, I want to give you a quick introductions of the unit. Since here I have utilized the Astronautic Unit, so here I want to give us a certain brief descriptions. And this one is in Appendix A. So here we call the AU. So again, the AU is the mean distance between the Earth and Sun. Okay, and this one pretty much commonly used for interplanetary planning of the trips. Okay, because that one we use this one will be convenient. And the other commonly used is DU. DU is another unit is the Earth's radius. And DU has been commonly used for describing say launching the satellites. So we're describing the distance of the satellites. We can scale it by the radius of the Earth and into the DU. Okay, and actually DU we have more different textbooks, and people would have more commonly use this one. And here in specific, if the people put the symbols like this one, it's indicating that is a unit referred to the radius of the Earth. Okay, and people will also refer to the DU, and here they use this symbol. Basically, this is equal to the mean distance between the Earth and Sun. Okay, and from our textbook, even I will continue. So you will see the DU, and then people, I've seen this before, using this one. Basically, that's taken is, you can guess the radius of the moon. Okay, so it depends on which problem, which kind of the scale you prefer to, you can always pick out something appropriate. Okay, and this one is used, been commonly used, the mostly used in our lectures here. Okay, and the third one is time unit, TU. And TU, basically here, everything is in our textbook appendix A. A TU is a time unit, and how to pick up a good time unit, and that one can be done by this. So that really has quite a few different definitions for TU, and here I want to describe is the one we adopt in our textbook. So one TU, basically by calculation, is this. We taking this as the information, so that will be equal to 2 pi multiply the radius of the Earth. The radius of the Earth, I forgot the. Here I have. So TU used in our appendix is being calculated by this. So that is du cubed divided by mu. Okay. So here I simply adopt this format for the relating to the time to the size of the orbit. So basically here we plug in the information. So that is let me finish this one. So here this calculated is 806 times 81187 seconds. And here there's a typo here. And don't use 2 pi. Okay, and that's the definition, again, that's the definition for defining the TU. In the appendix A, they calculate TU by using this one and no 2 pi. And I try to adopt all the things, but since they take away the scale, the scaling factor of the 2 pi. And don't ask me why, that is a definition. Definition, there's no reason, we simply define it. And people define it, we simply take it. Okay. And of course, if you're smiling, you can have your own definitions, and then you simply. And sometimes when we use those kind of the unit, scale unit, it's a little bit confusing. So I have another textbook, and this morning I kind of went through the whole textbook. That textbook simply just using the kilometers, second, this kind of unit, very persistent from the beginning to the end. And that's okay, and I prefer everyone to do it. And one downside of doing this is sometimes you'll be facing with a large number crunching, right? And if you have the scale to TU, DU, and that is the simple numbers when you write something, but sometimes confusion is from definition. Different textbooks, different people have a different definition of the TU, in particular TU here. Some people included 2 pi in their definition. And so that reason, again, in our appendix, the textbook, we adopt this one. So let me get rid of this, okay? So about 806 seconds, that is defined as a TU in this textbook, okay? So under these situations, then we can define the speed. And that is simply is 1 du divided by 1 tu. Okay. So du is the radius of the Earth, and tu is been given by this. So that has the numbers, and that number you simply can refer to appendix. And let me write up here. How about that? So here 1 du is equal to 7.905368 kilometer per second. Okay. So again, this is a derived quantity based upon the definition of TU. So that is quickly and in Appendix A. And Appendix A is the common one. If you in the future or in the homework you refer to the TU DU, then you simply refer to the appendix. Okay, and that is the number for we try to unify these things, then we stick with the appendix A.